In this lecture, we will introduce experimental design. Our learning objectives today are to explain the relevance of experimental design for improving quality and performance, and we want to design a 2x2 experiment calculating the main and the interaction effects. So far in this course, we have covered the important statistics for quality engineering necessary to understand how random variables can be measured using sampling. We have reviewed how to make inferences about our parameter populations using estimates from measured data, and we have analyzed our data using process capability indices and regression and correlation. Now we are interested in improving our process. And to do this, we need to design an experiment in order to vary product parameters to improve our output and to improve our process performance. There's a vast body of knowledge that exists on how to perform experiments efficiently, so that the required information about the product performance in relation to the product parameters is obtained with the minimum amount of experimental work. This branch of statistics is called the design of experiments, or DOE. And it was pioneered by Sir Ronald Fisher, the English statistician, who in the early 1920s was researching the selection of the best levels of inputs in order to maximize the yield from agricultural fields. So he was using parameters such as fertilizer, seed variety, amount of moisture, etc. The designed experiments were subsequently used profitably in industrial environments to optimize the selection of product parameters during product design and process parameters during process design. Now, when we say parameter design, we mean this refers to the selecting the product parameters, or those critical characteristics that determine a product's quality and the ability to meet the intended use of the product. Experimentation should be done using statistically designed experiments. And in this lecture, we will now look at the basis of experimental designs and how to set up a 2x2 factorial design. So, as we said in the very first lectures, based on customer expectations, the target values or the design features for the product parameters should be already decided. For example, a lawnmower has to mow a certain number of square meters in a certain time. In this case, the design team might have chosen the performance target as mowing an average yard of about 10,000 square feet in less than 1 hour. They might then decide on the product parameters, such as the blade size, the blade angle, engine horsepower, speed of rotation, chute angle, deck height, and so on. In order to accomplish the target performance, most product designers would already have initial values for these parameters based on their experience with previous models. And the question to be answered here is whether these initial values are good enough to meet the new targets or if they need to be changed to attain the new target for the new model. And often the answer has to be found through experimentation. That is, by trying different values for the product parameters, measuring corresponding performances, and choosing the set of parameters that gives the desired performance. So for this lawnmower example, we have to set up an experiment with the objective of finding the best set of values for the product parameters that will enable the cutting of a yard that is 10,000 square feet in size in 1 hour or less. The design of the experiment then involves selecting the levels of the different factors and then determining the combination of factors levels at which we should perform trials, or in lawnmower case, mowing the lawn. We also want to determine the sequence in which the trials will be run and how many times trials will be repeated at each combination of factor levels. An experimental design is usually accomplished by a procedure for analyzing the data that result from the trials. So there are many designs created by statisticians to suit many different circumstances where designs are needed. We cover here the class of experiments called factorial experiments, of which the 2x2 and 2x3 factorials are the most important. Experiment is designed to study the effect of some input variables called factors on a response, which may be the performance of a product or output of a process. As we said, the factors can be set at different levels. The product performance or the process output could change depending on the levels at which the different factors are kept. The design of experiment then involves choosing the relevant factors, selecting the appropriate levels for them, and determining the combination of factor levels called treatment combinations at which the trials will be conducted. The design determines the number of times the trials will be repeated with each treatment combination in order to obtain a measure of the random variability present in the results. In addition, the design will specify the sequence in which the trials should be run and is usually accompanied by a procedure for analyzing the data. A factorial experiment is an experiment where each level of one factor is combined with each level of every other factor to obtain the possible treatment combinations at which the trials are to be performed. So, when there are two factors and two levels in each factor, we have a 2x2 factorial design. So, consider the case of our lawnmower. The response is the time needed to cut a yard of 10,000 square feet. And the possible factors could be blade diameter, blade angle, rotation speed, engine horsepower, deck height, chute size, chute location, along with several others. But suppose for the new design of the lawnmower, only changes to two factors, the blade angle and the deck height, are considered for achieving the desired performance. For each of these factors, we will choose high level and a low level. These parameters are chosen based on past experience and past models, and the value for the experiment are varied with the expectation that the different combinations will guide us to an optimal mowing speed to meet our target. So for this example, the two levels for the factor blade angle will be 12 degrees and 16 degrees. And the two levels for the factor B, deck height, will be 5 inches and 7 inches. And what we want to do now is to find the best combination of blade angle and deck height for achieving the desired performance. The 2x2 factorial design for the lawnmower could also be represented in a table as shown here. So let's go through this table. The lower level of each factor is designated by a minus sign, and the higher level is designated by a plus sign. The design is to run the experiment at the 4 treatment combinations numbered 1, 2, 3, and 4. Now, for example, in treatment combination 1, we have both factors at the low level. In treatment combination 2, we have factor A at the high level and factor B at the low level, and so forth. Now, in addition, the experimental design recommends that 2 trials be run at each treatment combination to obtain 2 replicates. That's what we show here. So, for treatment level 1, when both factors are at a low level, we run the experiment once and we get the value 72 minutes. We run it again and we get the value 74 minutes. The results of these are then averaged. Average is 73 minutes. And the averages will be used as the response from the treatment combination. Now, the number of replicates needed is determined based on the variability expected from the individual trials, as well as the cost associated with and the time available for repeating the trials. So at least 2 replicates are necessary for the 2 and 3 factorial experiments to obtain an estimate for the experimental error. So let's look at these numbers one time here. For the different treatment combinations 1 to 4, we have the values 73, 48, 60, and 83. We'll be using this example through this lecture. So now, just a word on randomization. Noise refers to the environmental conditions that are not deliberately changed as part of the experiment, but changes in them may influence our experimental results. Now, for example, in the case of our lawnmower, we would like to perform the experiment with different treatment combinations on the same piece of yard so that things other than the experimental factors will remain the same for all treatment conversations. But because we can't mow one piece of yard over and over, it's not possible to do this. We have to repeat the experiment with different treatment combinations on different yards or similar yards of equal size. And when we're using different yards, there may be differences in the yards because of small differences in the size or the slope of the yard or weeds or wet patches and so on. And these small differences will cause variability in the results outside of the effects due to our factor levels being investigated. Now, replicates allow us to evaluate this variability. And the averages from the replicates, when used as the response from the treatment combinations, will contain less variability from such noise as compared to the single readings from individual trials. And just as noise or extraneous factors can cause variability in replicates that are run with the same treatment combinations, noise factors can also affect outcomes between 2 treatment combinations, either by masking or adding to the factor effects. An example, supposing dry grass in the afternoon may require less time to cut than moist grass in the morning. The morning-afternoon effect will add to or subtract from the real effect of the factors. And so therefore, care should be taken to avoid the morning-afternoon effect when we're doing our lawn mowing test. So to remove, or at least to minimize the effect of noise, the trials must be randomized. In other words, the trials are not run in the order indicated in the design. Instead, they are run in a randomly chosen order. Randomizing prevents the noise factors from affecting the trial systematically and minimizes the influence of noise factors on the trial outcomes. In the example of the lawnmower, the 8 trials can be randomly assigned to 8 different yards of approximately 10,000 square feet and otherwise similar in all other aspects. And the 8 trials can be run in a random sequence using one single lawnmower operator.